All right, so what I want to talk about right now is the addition principle of equality with the purpose of solving equations. So we've talked previously about equations. Equations have an equal sign in them, and these equations are going to have variables. Remember, variables usually are in the form of letters, and they represent numbers that or amounts that we don't quite know yet. But we're going to figure out a way now to solve for those unknown variables. And what I've drawn here is this this balance of, this represents a balanced equation. We've got this side over here, the left, with A and B over here. And what I wanted to show is that if I were to add this small box with the A side, if I included that same small box on the left side, or excuse me, the right side of the equal sign, then my equation would continue to be balanced. Now, if I added, say, a box over to this side, but not over here, then of course, it would probably tip, and it would look more kind of like this because it would be heavier, something like this. But because we are adding the same amount to both sides, then both sides will continue to be balanced. The same thing if we were to take away, say my A side originally, or my left side had these two boxes, one smaller than the other, and size here doesn't matter. But say I took away the small box here, okay, and I just had this larger box, but I did not take away the small box here, then of course this side would be heavier, and you would have something, kind of like this, where you had, the larger box and then the smaller box, but then the left side would be lighter. And so what I'm trying to explain here through the illustration is that if I add something, or if I take away something from one side, I want to do the same thing to the other side of the equal sign, so that the equation is going to be equivalent. Okay, and so let's go ahead and play around with some number equations instead of drawing pictures here. Although I think that's a decent model to get you in the get you thinking about what we're doing here. So let's start off with an easy one. Let's say we have x, and we're going to add to that 6, and I'm going to say this is going to be equivalent to negative 13. Okay, now what we want to do is isolate our variable so that everything will be on the other side. All the numbers will be on the other side of the equal sign, and so then we can have a definitive answer or representation for that x. Now, to move things, we can't just say, okay, I'm going to move this 6 and put it over here. Remember that that balance that we were talking about. If we add something to this side, we have to add something to this side so that it continues to be a balanced equation. Additionally, if we subtract something, we want to subtract over on this side as well. So let's just go ahead and think about how we can eliminate this positive 6 instead of just rewriting it and moving it over here. What we want to do is have x by itself. So if we were to subtract or add the opposite of positive 6, we would get x plus 0. And hopefully you know that x plus 0 is really the same thing as x. So by adding the opposite of a positive 6, and I'll rewrite that, x plus 6 plus the opposite of positive 6, which is really a negative 6, then I'm going to get a 0 when I combine these two. Now remember, I want to do the same thing on the other side so I can keep the balance of the equation. And notice I'm adding the opposite of positive 6 So on the right side, I also want to add the opposite of a positive 6, which really is, I'm adding a negative 6. Now, like I said, we're going to take that. We've got 0, negative 13 plus negative 6. Two negatives when we add we're basically going to add, so that's a negative 19. And again, x plus 0 is the same thing as x equals negative 19. Now, it's important to take this negative 19 and plug it back into the original equation to make sure that you're going to get a true statement. So if I were to take this negative 19 and plug it in where the x is, add 6 to that, and what I'm trying to figure out is, is this going to in fact equal negative 13? Now, negative 19 plus 6, really we're going to subtract, and the answer will take the sign of the higher number, and we are going to get 13, so negative 13 indeed equals negative 13. So this is a true statement. So our solution for this original equation is going to be this number here, negative 19. Okay, what I'd like to do is go through a couple of examples so you get some additional practice in, and feel free to do the problems with me. All right, let's do another one, and it's going to look slightly different. In this case, we added the opposite, which is a negative. In this next example, we're going to add the opposite, which is going to happen to be a positive number. And it might look something like this. So let's say negative 8 equals x minus 10. And again, we want x by itself. We have to get rid of this part here. It's a negative number. So let's add the opposite of a negative, which will be a positive. And so I'll go ahead and write this part out, and then we can fill this in. So we've got x minus 10 plus the opposite of negative 10, so that's going to be plus or positive 10, which is just going to be 10. So knowing that I'm adding 10, I'm going to add 10 to the left side. Okay. Now, this, of course, negative 10 plus 10, that's going to give me 0. Okay. And then, of course, here, negative 8 plus 10, we're really subtracting. It's going to be a positive because this is the higher number, so we've got 2. So x equals 2. Now, to check our solution, we're going to plug it in and then evaluate. So negative x, and does that really equal 2 minus 10? Well, this is a positive 2 minus 10. We're going to subtract, and we're going to take the negative. So that is going to give us negative 8. That's a true statement. And so the solution is 2 for this equation. Okay, let's do one with a fraction and a decimal just to get some additional practice working with those types of numbers. First one is going to be a fraction, and let's say we've got x plus 1/4 equals 7/4. And we're not going to do one where you've got to find a common denominator. We'll try to keep it easy here for you. So again, we want to isolate the x. We want to add the opposite. So this is a positive 1/4, and so we're basically going to be subtracting 1/4. Now, previously I was writing it out, and I'll go ahead and write it out that way, but I'm going to show you another way we could write it out. So this is what we've been doing, 1/4 plus negative 1/4, and then of course do the same thing on the other side, plus negative 1/4. All right, and then we get x plus 0, and then 7/4 plus a negative 1/4. When we have common denominators, we're going to just add 7 plus the negative, which is 6/4, positive 6/4. So x equals 6/4. And then, of course, we would plug it in and check. But let me show you another way. I'm gonna rewrite this, and then I'm going to show you another way to write it out. Okay? And then you can decide which way you want to do it. So x plus 1/4 equals 7/4. Now, knowing that I want to add the opposite, I'm going to go ahead and write underneath, I'm going to subtract 1/4. And so I'm doing that. And then I like to draw a little line. Now, x plus 1/4 minus 1/4, the x comes down. This is going to be a 0. And you could put plus 0 or minus 0. But because it's going to be a 0, you know, and eventually I'm going to just not write it down, I'm going to skip that part and then just come over here. So 7/4 minus 1/4 is going to give me 6/4. Now let's go ahead and check just to make sure that that's the solution. So I'm going to say 6/4 plus 1/4, and does that equal 7/4? Well, again, we have common denominators. We're just going to add 6 plus 1. That is going to give us 7/4. And so that's a true statement. So the solution is 6/4. Now, of course, if you have an improper, you could convert it to a mixed number and, of course, reduce. So that'd be 1 2/4, or you can go 1 1/2. Okay. Let's do one more where we're working with decimals, and we'll basically be practicing adding the opposite so that we can isolate that variable. Let's say we have negative 9.3 equals negative 4.2 plus x. Again, I want this by itself. I'm going to do the opposite. This is a negative, so I'm going to add. I'm going to write it underneath plus 4.2. I'm going to add 4.2, and that's going to basically cancel. So we've got x equals, and then when we have a negative and we're adding a positive, we're basically subtracting, and the answer will take the higher sign. So that's going to be 1 and 5. So negative 5.1. Now, what I want to do is plug that into the original equation. Negative 9.3 equals negative 4.2 plus negative 5.1. When I'm adding two negatives, I'm just going to add them together, and it will be negative. That's going to be 3. 9.3 is the same or equivalent to 9.3. And so my solution is not the 9.3. It's going to be this number here. Okay, that's my solution. So like always, if you have questions, make sure you ask in class. We're getting into the fun stuff now. And anyway, that's it.